Hello everyone, myself here, and today we will be solving question C of Codeforces round 1096, div 3. So, what does this question says is we have given an array of n positive integers, and they have defined f of a such that the number it is equal to number of subarrays of a whose product is divisible by 6. So, firstly, let me just tell you how can we conclude that a number is divisible by 6 or not. So let's say so firstly, let us take out prime factorization of 6. Okay. So 2 threes are and 3 ones are. Okay. So we got the prime factors of 6 as 2 and 3. So any number which consists of at least 1, 2, 1, 2 and 1, 3 will be able to 6 will be able to divide 6 will be able to divide that number. For an example, let us take an example of 12 and one more example, like let's say 15. Okay, so firstly let us take out prime factorization of this. So 12 would be 2 6 are 2 3s are and 3 1s are. So it consists of 2 2s and 1 3. And if we want to make it divisible by 6, we know that 6 will be divisible if it consists of 1 2 and 1 3. So it consists of 1 2 and 1 3. So 6 will be able to divide 12 completely. Now let us take a let us see for 15. So prime factorization of 15 would be 5 3s and 3 1s are. Okay, so 5 and 3. But now we can see that we don't have a 2, we want 2 at least once, but it is not present here. So we will tell that 6 won't be able to 6 will not be able to divide 15 completely. So it won't be divisible by 6. 15 won't be divisible by 6. Okay. So now our task is to reorder the elements of array A such that f of A would be minimized, which means that the product of the subarrays of A would be minimized. So we have to find a array where we have to minimize the product of a numbers which are not divisible by 6. So let us take an example. Let us take first example. Okay. So we have given numbers 12, 7, 9, 4, 18, 5. Okay. Now, we all know that subarray is the contiguous element, elements of an array. For an example, this can be called a subarray. This can be called a subarray. This can also be called a subarray. The whole array can also be called a subarray. Okay. But this two part and this two part together won't be able to call an subarray because there is a gap in between. There shouldn't be any gap. Okay. So let us again write the example. 9, 4, 18, and 5. Okay. Now, we know that the prime factors of 12 would be 2, 2, 3. Prime factors of 7 would be 7, only 7. Okay. Prime factors of 9 would be 3, 3. Prime factors of 4 would be 2, 2. Prime factors of 18 would be 3, 3, 2. Prime factors of 5 would be 5. Okay. Now, we have to calculate all we have to take in the we have to take into consideration of all these subarrays. Okay, so like we can say that if we are multiplying this element with this element, which means 12 into 7. Okay, so this subarray would always consist 1 2 and 1 3 because it consists inside the 12. So this would always be divisible by 6. Okay, now if we are take a single element 12, that would also be divisible, completely divisible by 6 because it consists of 1 2 and 1 3. So any subarray which consists of 12 would always be divisible by 6 because this element itself consists of 1 2 and 1 3. Similarly, if for an example, if we multiply if we take a subarray 9 and 4, this would also be divisible by 6 because 9 consists of 1 3 and 4 consists of 1 2. So any subarray which consists of 2 and 3, any subarray which consists of 9 and 4 would together be divisible by 6 because 9 will consist of 1 3 and 4 will consist of 1 2. Okay, so we need to reorder these elements in such a way that it would be minimized. The product of the number that are divisible by 6 should be minimized. Okay, so now let us see the answer how they are rearranged it. So they have rearranged it 12, 18, 4, 7, 5, and 9. Now let us just write the prime factors of this 2, 2, 3, 3, 3, 2, 2, 2, 7, 5, 3, 3. Now we can see that here any subarray that consists of 12 would always be divisible by 6. So this element would be divisible by 6. This subarray 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 would be divisible by 6 and this subarray would be divisible by 6. Similarly, any subarray which consists of 18 would always be divisible by 6. So this single element 18 would be divisible by 6. This and 4 would be divisible by 6. So any subarray which consists of 12 or 18 would always be divisible by 6. Okay. Now let us move ahead. So 4. So now we know that 4 consists of 1, 2. So if any other element which consists of 1, 3, and if it is inside the product or if it is inside the subarray, then it will be able to, like, it will be divisible by 6. For an example, if we take 18 and 4, then it will be able to divisible by 6 because 4 consists of 1, 2 and 18 consists of 1, 3. Okay, so any element which consists of one more 3 along with the 4 will be able to divisible by 6. Now let us move ahead. So for an example, if we take an example this 7 and 5 subarray, okay, 7 and 5. So here prime factors of 7 are 7, prime factor of 5 are 5. Okay, so it doesn't, like, this both element does not contain single at least one or at least 3. So this together won't be able to divisible by 6. So this array won't be sub array won't be able to divisible by 6. This single element 7 won't be able to divisible by 6, and this 5 would, like, it will also be not divisible by 6. Okay, now this sub array, let us consider this sub array 759. Okay, 759. This consists of 3 comma 3. This consists of 5 and this consists of 7. Now we can see that here there is at least one, but we could not form at least one, two. So this subarray also won't be able to divisible by 6. So now we have to rearrange it in such a way that we are able to minimize f of a, that is number of subarrays which are divisible by 6. So we have to minimize that. So how can we do that? Okay. So let us just try to form some, oh, just a second. Okay. Now let us just try to form some conclusion over this problem. So what we can do is, like, let us just take one more example. 1, 10, 15, 20, 3, 6, 9. Okay. So now, like, what we can, we can rearrange it in such a way that, let's say, firstly we rearrange all the elements that are the single element is completely divisible by 6. For an example, uh, this 6. 6 is completely divisible by 6. Okay. So we will put at the first position. Okay. And none of the other element is completely divisible by 6. Okay. So firstly, we will take all the elements which are completely divisible by 6 and we will put it inside the starting position. Okay. Inside the first position. So if there are one more elements, let's say 12, which is completely divisible by 6, then we will put at the starting position. At the end, I will tell you why we are thinking this way. Okay. So let me just remove 12. After that, we will be taking those elements which consist of at least 1, 2, and it doesn't consist of 3. So this consists of 2, but it doesn't consist of 3. So we will add this point. This this consists of 3, so we won't be able to add it. This does not consist of 3. It only consists at least 1, 2. So we will add that as well. Okay, that's it. After that, we will add those elements which are which does not have single at least 1, 2 or at least 1, 3. Let's say this example, or if you want to take one more example, then that would be 37. 7. They don't consist of at least 1, 2 or 1, 3. So we will add those elements after this. So let me just add it. And after that, we will add those elements which does not consist of at least 1, 2, and it consists of at least 1, 3. So this element consists of 1, 3. This element consists of 1, 3. And this element consists of 1, 3. And they all does not contain 2, a single 2. Okay. So we will add those. Now, why we are doing this? Let me just write it. This consists of 2 and 3. This consists of only 2. Node 2 and 3. only 3. Okay, now why we are doing this? Okay, so we know that if any element which consists of 2 and 3, and if it is present inside a subarray, like any other subarray, then it would always be able to divisible by 6. So this would be divisible by 6, this subarray would be divisible by 6. Okay, so rest of the element which like any subarray which consists of 6 would always be divisible by 6. Okay, now like here, they are only divisible by 2. We need at least one 3. So let us take this subarray. Okay. Now we know that this does not consist of any 2 or 3. And this only consists of 2. So we required one more 3 to make it divisible by 6. But we won't be able to find it because we have arranged it in such a way that after any element which is divisible, which consists of 2 and does not consist of 3, after that there will be those elements which are not divisible by 2 or divisible by 3. Okay, so this subarray won't be able to divisible by 6. This uh, this single element won't be able to divisible by 6. This subarray won't be able to divisible by 6. This subarray won't be able to divisible by 6. Okay, so and after that, let us take this example. 20 and 1 won't be able to divisible by 6 because it does not consist of 3. So we have rearranged in such a way that like we are rearranging it in such a way that we don't find any 3 after we found 2. Okay. Yeah, I know that this subarray would be able to divisible by 6 because they will get 3 from here and 2 from here. But we are like our task is to minimize it, and we have reduced some of the subarrays which does not consist of 2 and 3. Similarly, this won't be able to divisible by 6 because this does not consist of any 2 and this also does not consist of any 2. So this whole subarray won't be able to divisible by 6. So we will be rearranging it in such a way that firstly all elements that are divisible by 2 and 3. Then we will add those elements which are divisible by only 2. Then we will add those elements which are not divisible by 2 and 3. Then we will add those elements which are only divisible by 3. Okay. So we will try to form the array in this way. So if we form the array in this way, then we will be able to minimize f of a, which is our final task. So let me just show you the code of this problem. See, firstly, we took the input from the user. Then we have made three vectors. One consists of all the elements which are divisible by only 2, which like all the elements which are divisible by 2 and 3, and all those elements which are divisible by only 3 will be stored here. Okay. Then we initialize the loop, and if the element is divisible by 2 and 3, then we will be adding those elements in f of a. We flagged it to 1. Okay, so we can remember it that that element is divisible by both 2 and 3. If the element is only divisible by 2, then we flag that position to 1 so that we can remember that it is only divisible by 2. And at the last, if it is divisible by 3, then we did the same as we did previously. After that, I initialized one more loop and added all those elements which are divisible by 2 and 3. Then I again initialized one more loop which consists of all the elements that are only divisible by 2 and it does not consist of any numbers which are divisible by 3. Okay. After that, I add all those elements which are not divisible by 2 and 3 both. And at the last, we added those elements which are only divisible by 3 and are not divisible by 2. So in this way, we are able to form the array which minimize f of a. So this was the question 3 of div 3, code forces round 1096. Thank you.